Hey everyone, welcome to this explainer. Today, we are going to completely debunk the biggest myth in modern technology. We're going to peel back the layers and uncover what is actually happening right beneath the signal of modern wireless networks. If you've ever glanced down at that little 5G icon on your phone and thought to yourself, okay, my internet is slightly faster, but is that it? Well, your instincts are spot on. You are absolutely right to question it, because that slightly faster connection, it doesn't even come close to telling the whole story of this massive technological leap. What we're really talking about today is the hidden intelligence of 5G.
So let's just get the elephant in the room out of the way and ask the question that pretty much everyone assumes they already know the answer to. Is 5G really just about faster downloads? Honestly, no. Because the reality is, raw speed is actually the absolute least interesting part of this entire technology. For decades now, we have been conditioned to think that every single new generation of wireless tech is simply about building a bigger, faster pipe to cram more data into our smartphones. But the truth of what 5G is actually doing in the background, the way it actually operates, is so much more fascinating than just faster movie downloads.
You see, the real problem being solved by modern networks isn't just about widening that data pipe. It's about a fundamental shift in the whole goal of the system. Instead of just mindlessly moving data from point A to point B as fast as it can, the network now has to adapt intelligently to whatever the current situation demands. Think about it. Older networks had a very simple, very straightforward mission, right? Connect people and move their data quickly. That was the whole job. But 5G completely changes what the network is actually allowed to care about. It's shifting from just move it to understand what you're moving and adapt.
To really picture this, think of a super busy public highway. Now, it's not nearly enough for that road to just be built for pure speed, if, at the same time, it has to safely handle heavy, slow-moving freight trucks, speeding sports cars, and entirely unpredictable crowds of pedestrians. If you just let all of that loose on a fast road, everything would collapse into total chaos. Well, a digital network faces that exact same challenge. If you only design your system for one type of extremely fast car, the whole thing completely breaks down the absolute second a delivery truck or a pedestrian needs to use it safely.
This brings us to a really cool balancing act. Every network is basically caught in an invisible tug-of-war between three competing tensions: speed, responsiveness, and efficiency. And it's a delicate balance. If a system goes all in and over-focuses purely on speed, it might completely drop the ball for a machine that desperately needs an instant, reliable response. But on the flip side, if you only care about being super efficient and saving resources, the whole system slows down for everyone. What makes 5G so incredibly different is that it's actually built to balance all three of these competing tensions simultaneously, rather than just brute-forcing speed and ignoring everything else.
So, how does it do that? To understand this hidden layer of intelligence, imagine a massive, highly complex train station. The network isn't smarter just because the trains themselves are moving faster. It's smarter because it actively routes the right kind of traffic onto the right kind of tracks. I mean, you would never put a slow, incredibly heavy freight train on the exact same track as a high-speed commuter bullet train, right? That would be a disaster. Well, 5G actually does this digitally. It creates distinct, completely invisible lanes, tailored for entirely different needs.
Because it has these invisible lanes, the network can actually recognize what's going on. It knows that a smooth video stream on your tablet, a robotic arm in a factory that needs an instant reflex, and a tiny temperature sensor sending out little blips of data all day all require completely different types of connections. They aren't just different users, they are entirely different jobs. Think about it. A video buffering for half a second is totally fine for a human watching a movie. We barely notice it. But for a remote-controlled machine, that exact same half second is an absolute eternity that could cause a literal disaster.
The intelligence we're talking about here is just highly, highly practical. Honestly, it's a lot like a master chef running a super busy restaurant kitchen. That chef knows exactly when to rush an urgent dish and exactly when to hold back a sauce so that every single order at the table finishes perfectly at the exact same time. Now, obviously, the network doesn't think like a conscious human being, but it is deeply situation aware. It manages the timing, the priority, and the resources to make sure every digital dish is served exactly the way it needs to be.
So, the absolutely crucial takeaway here is flexibility, total flexibility. It's kind of like a modular home that can seamlessly change a quiet study into a bustling guest room based on who happens to be visiting that day. The network literally shapes itself around the immediate, real-time situation instead of forcing every single user into one rigid mold. And guys, this is a massive, massive departure from older systems, where every new device, whether it was a smartwatch or a smart car, had to just try and squeeze itself into one single, uniform way of connecting.
Which brings us to a critical, absolutely foundational concept: delay, or as network folks call it, latency. Imagine the difference between saying, I got a huge file but it took a while, versus I got a tiny response but it arrived too late. For a lot of complex automated machines, receiving a tiny piece of information just a fraction of a second too late is way more catastrophic than waiting a few extra seconds for a massive movie file to load. As humans, we just get mildly annoyed by a slow download, but machines, safety systems, automated infrastructure, they fail entirely if a single-line instruction misses its window.
And this right here is exactly why low delay, that instant responsiveness, is such a monumental deal in modern networks. The network isn't just mindlessly dumping data anymore, it is actively managing hyper-precise timing. We're talking about systems where a delayed reflex is incredibly dangerous. Picture automated factories, ultra-precise remote operations, complex logistics grids. In those worlds, absolute predictability is literally the most valuable metric there is. It vastly outshines raw data speed every single time.
But wait, there is another kind of immense pressure this hidden intelligence has to deal with. And that is the sheer, unadulterated chaos of thousands of tiny, simultaneous connections. Imagine thousands of smart sensors or building monitors, all crying out for attention at the exact same millisecond. The network has to have the capacity to hear thousands of these tiny little whispers all at once, and it has to do it without ever letting a few shouting voices, like, say, someone downloading a massive 4K video, drown everyone else out.
Just imagine being at a massively crowded public event. You've got tens of thousands of people trying to stream video, sending text messages, posting photos. And meanwhile, local machines, payment terminals, and security cameras are all trying to operate in that exact same space. The network's hidden intelligence avoids a total system crash by not wasting heavy, precious resources treating a tiny text message or a sensor report like it's a high-definition video download. It beautifully organizes the chaos by recognizing exactly what each connection actually needs to just function properly in real time. By stepping up and acting as a selective traffic manager, the network is able to give exactly the right kind of support to each specific situation, without collapsing under the weight of the crowd. It effortlessly handles the continuous, heavy flow you need for video streaming. It instantly provides the lightning-fast, zero-delay ping required for machine controls. And it manages the incredible density of massive crowds, all seamlessly. It's essentially custom tailoring the network on the fly for every single connection.
And right there, that is the paradigm shift laid bare. Older thinking forced everyone into one behavioral lane, treating all data as equal but rigid. Every connection gets handled mostly the same way. But this new approach totally rewrites the rulebook. It acknowledges that different connections fundamentally deserve completely different treatment. This selective, tailored treatment is what we are really talking about when we say this network has hidden intelligence. It isn't just working harder and pushing more data. It is finally working much, much smarter.
So this is exactly why we are looking at a completely new network design rather than just a simple speed bump. This is an intelligent, context-aware platform built from the ground up around choice, around priority, and around adapting to demands we frankly haven't even invented yet. It is the invisible foundation ensuring that the digital infrastructure of tomorrow won't just crack under the weight of totally different types of technology, all needing to communicate side by side. It is a completely new operating logic. So the very next time you hear this technology mentioned, remember that the true innovation of 5G is not speed alone, but a network that can adapt its behavior to different needs. Thank you so much for joining me on this explainer to unpack the hidden intelligence right beneath the signal. But honestly, it leaves us with one final, pretty wild thought to chew on. If our networks are now actually smart enough to adapt to any machine we can possibly dream up, what totally new, seemingly impossible technologies are we going to be forced to invent next just to fill that space?